So I think your concentration should be okay. So we are going to start with something which is called the Milne Thompson method. So we are actually discussing about analytic function in this particular unit, and we are going to continue with that. It's actually a very vast topic, although the syllabus shows that it's actually not that long, but if you just take up problems and try to solve them, you see there are a lot of different kinds of problems. You have to know a lot of techniques of solving differential and integrals using the methods that you might have learned in your undergraduation and even in your class 11 12. Okay, so what we are going to do now is we are going to construct analytic function. We have done it partially before also, but we are going to use a method which is actually called the Thompson-Milne method. Okay, we're going to use this and we are going to design an analytic function, right? So for designing an analytic function, u plus iv, what I need is the value of u and the value of v. So if I've given u, I can find out v. If I'm given v, I can find out u. Okay, and we are going to do that. But for that, we are just going to use this Milne Thompson method. And before that, let me just analyze this example. If we basically have, let's say, fz is equal to z cubed, we can actually write it down in terms of x and y, right? So it is x plus iy, and whenever we are doing any kind of analytic analysis of a function, we basically divide it into the real part and the imaginary part. So it can be a cubed plus 3a square b, right, plus 3ab square, okay, and then plus b cubed. So we can do it this way. And if we just combine the real part and the imaginary part, I can simply write it down as x cubed, and this is a square there, so this will become a real part now, minus 3xy square plus, and then we can take I, and then 3x square y. Okay, 3x square y is this I, and with this is the minus of y cubed. So we have the real part and the imaginary part, and when we actually write it down, we can write it down as uxy, okay, is equal to x cubed minus 3xy square. Okay, that's your u. And then we can also have v, and v can also be a function of y. If it's separated out in x and y, the sums becomes much more easy, but then mostly you'll see that it's not that simple, and mostly you're going to get a mix of x and y. So that's why you need to know different methods, and that's very important. Okay, so if we just take this example, a question which might be there is like this. Okay, maybe I can give you this. If this is something which is already given, okay, this is just a prelude that that okay, this is the case. I'm just explaining this so that it becomes clear for all of us. Now if u is equal to x cubed minus 3xy square, okay, and is real part, questions might be something like this. Okay, you get in your exams, real part. If you get an entrance exam, there will be a multiple choice question which you can do even much more easily. Probably will do it by the end of the unit. So if this is a real part of the analytic function, okay, fz is the real part, then the question is, then find fz. So this kind of questions are common, and this might be a question. See, you are given the real part, you have to find out the imaginary part. Okay, that means you have to just find out v. If you know u and v, then definitely you can write down what is your fz, right? So we usually try to do it in this way. Okay, and this is already given, and from here to here, how do we find out this v? It's something which we can actually do by using the Milne Thompson method. Okay, so I hope the idea for today's class is clear, and we are going to tackle these kind of problems now. Okay, so let's try Milne Thompson method. We're not going to go for anything which is complex. We're just going to write down the method, and then we are going to solve the problems. Okay, that's important. So Milne Thompson method. So let's do it. So what does it Milne Thompson method say is that you already have u, let's say, and then I can write down del u del x as, let's say I'll take a function phi1, and then I'll put the coordinate of x as z and coordinate y of 0. Okay, and then I can take del u del y, and here I can take it to be another function phi 2, and here also I'll do the coordinate of x as z and the coordinate of y as 0. Okay, and this is the method, and if we just use this we can actually find out what is the function. So this is the first problem, so I'll try to solve it. Fz, and then you have the integration, and it will be like this. Okay, phi 1 z0 minus I phi 2 z0 dz plus c. Okay, so this will be the function. So this becomes easy if we know this method to actually find out. So in exam maybe I'll ask you a question, and then probably I won't mention which method you're supposed to use to find out the analytic function, and you can use any of them. Okay, but then if you use Milne Thompson method, it is one of the simplest method to find out the analytic function fz, and we are going to just look into this. Okay, so let's just have a quick look at the solution. I am sure that some of you have already done it. It's very simple, but then let me just do it here. Okay, so that means I need to find out del u del x. U is already given, so I'm solving it now. So you can take del u del x. Okay, so this will be 3x square minus 3y square. You have to be very conversant with integration and differentiation and so on. Okay, so if I can just take this, I can write down this as phi 1 z of 0. This is equal to phi 1 z 0. So in place of x I will put z. So in place of x I will put z. In place of y I will put 0. So that means this would be just 3z square. Okay, so just be clear. And then what we can do is we can just find out del u del y is equal to, so we can just take out del u del y. See this is not y, this is y. So it is minus 6xy. In place of y we'll put 0, so this is phi 2 becomes 0. So if we just want to find out the analytic function now, it becomes so simple here. Just integrate it, phi 1 z0, that is 3z square minus I into phi 2. Phi 2 is 0, so I'll just take it to be phi 2, and this is dz plus c, right? So you can just integrate this. This is 0, this is 3z square, so you can take out 3. This is just z cubed divided by 3 plus c, so you get it to be z cubed. So see, this is the one that we are actually finding out. So see, this is z cubed, and we did say that we actually started from z cubed. So this is just a way to verify that yes, Milne Thompson method works. Okay, that's the only thing that I'm doing. That's why I've analyzed it first, and then I've used Milne Thompson method to find out the function. Okay, so we're going to get different kinds of problems. Okay, these kind of problems are actually very common, and we can actually do n number of numericals based on this technique. Let me just explain for v. Let's say you are given v, that means you are given the imaginary part, coefficient of the imaginary part. Let's just try to find out what can be the possible values. Okay, v is equal to 3 times x square y minus y cubed. Okay, is the imaginary part. Okay, I'll just complete the question here of analytic function fz, right? Question is then find fz. So I'll keep on doing it on the screen, and then you also keep on doing it. Okay, and definitely you're going to get it. It's going to be very easy. But then there is certain change in the formula when the imaginary part is given and you are supposed to find out the real part. What's the change? Let's just do it. We are going to find out del v del y. Remember del u del x was there. Here we are going to find out del v del y, and this should be equal to phi 1. Yeah.
The minus I z cube plus c.
Okay, maybe. Let's just do it. Okay, let's just do it so that everyone of us are on the same page. And del v divided by del x is equal to phi 2 z 0. Okay, so this is nothing but del v del y, and this is del v del x. We're going to do it, and let's just find it out fast. Okay, let's do it. Del v del y, it's 3x square minus 3y square, right? So that means if I want to find out phi 1 z0, this is not going just going to be 3z square, right? And on a similar note, if we just find out del v del x, all of you do it on your own. Okay, it's very important. It is 6xy, 6xy, so that means phi of 2z0 is equal to 0. Yeah, yeah.
So phi 1 is del v by del x or del y.
Yeah, that's the thing. That's the trick. The thing is, when you do it for v, I was going to explain that later, but since you asked, let me explain it now. When we talk about v, we have to take del v del y first, and that would be your phi 1. Okay, and that's the important thing that you need to remember. Okay, but I will write it down later. Just check it, and I will explain it in one single line so that it becomes easy for all of you to remember. So that means the formula that we are going to take is fz is equal to integration of phi 1 z0, and then if you have this phi 2, in fact the answer that you're going to get should be in terms of plus, so it is plus I of phi 2 z0. That's why I'm doing a problem with v, so that it becomes a bit clear for you. This is dz plus c. Okay, so if I just, probably I should write down a note here so that all of you are very clear about it. Plus and not minus. Okay, so this is important. For plus is for v, and minus is when u is given. So v is given, you use plus, u is given, you use minus. Okay, when it's v, this is del v del y. Okay, let me explain it here. Del y. When v is given, this is del v del x, right? And when u is given, it is del u del x, and when u is given, this is del u del y. So I think this makes it clear. Okay, please make sure this is v given, this is u given. You can just remember it one go. I think it's not a big deal. This is u given, right? And if you do it, you are going to get a different answer than what you are expecting. And this is v given. So please don't make that mistake. Okay, this is important. You have to remember it so that you are not confused.
So can you repeat this again?
You want me to repeat it?
Yes, sir. So no,
Okay.
this is the note part.
Okay, I'll explain this. Let's just finish this first. I'll probably write it down on a fresh slide. So that means if I want to find out fz, we have to write it down as integration phi 1. So our phi 1 is 3z square, phi 2 is 0, so I put it as 0 dz plus c. So in fact, you are also getting this as the same answer, z cube plus c. Now you missed a trick here. If you remember the problem that, or the example that I discussed here, actually the v was 3x square y minus y cubed. So obviously, if this is the imaginary part, and if you are using Milne Thompson method to find out the function fz, it should again be z cubed only. It cannot be anything else, right? Because these and these are nothing but conjugate of each other, right? One is the real part, one is the imaginary part, and this was 3x square y minus y cubed, and that's why I explained it in this way. Okay, and let me explain the formula once again so that all of us remember this. Okay, so it's u is given now. We know that u is given. Okay, you have to use this formula del u del x. This is easy to remember, right? This is phi 1. z0 obviously. z0 is applicable everywhere. And del u del y is equal to phi 2 z0. that's my, the differentiation value. And if I want to find out the analytic function, the formula is del u, or I can just simply write it down, phi 1 z0 plus, sorry, minus, it's u, you can screen it up. This is phi 1 z0 minus I phi 2 z0. This is the formula that we use when u is given. Right, now let's say u is not given, v is given, then it changes, and we have got del v and del y. The first function, that means phi, is with respect to y and not x. This is phi 1 z0, and if we take up del v, del x would be the second function. This is phi 2 z0. So that means the function fz is equal to integration of phi 1 z0, and it's a plus now, not a minus, so it's plus I times phi 2 z0 dz plus c. Okay, so now you check this and see if there is any kind of confusion. You have to just remember it conventionally. Just remember u, that's it. Don't remember v, just remember u. Other one you can easily recall. The first thing is, it won't be a plus, it will be only a minus, it will be a plus, and the first function won't be with respect to x, the first function will be with respect to y. These are the changes, and the second function will obviously be with respect to x. Okay, so just remember for u, easily you can recall v. Okay, it's not going to be very difficult. Okay, so that's your Milne Thompson method. I'm not going to take too many examples for this, because there is nothing new whatever example I'm going to do. Okay, this is the one that you have to understand. You have to just remember this formula and use it accordingly, and that's it. Okay, so isko aise use karna hai. Okay, let's go to a new kind of problem. Okay, where we actually can find out the entire analytic function if you are given a value. Okay, now I'll give you this example, and straight away your instinct will say a different approach, but that's not the correct approach. Suppose you are given u plus u minus v, okay, minus v, let's say, is equal to, I'll take this example, x minus y into x square plus 4xy plus y square. So given this function. Okay, and what you have to do, I think you can guess, you have to find out the analytic function. Okay, the question is, find analytic function. Someone's mic is on, can you just switch it off? Fz is equal to u plus iv. Although it is good, because I can feel that you're writing something, so making your notes, that's important. So this is the question, u minus v is given, you're supposed to find out the analytic function u plus iv. So our instinct might say, what's the harm, I can just put an I. Okay, but then here you don't know where you're supposed to put the I on the right hand side. Okay, so that's why we are going to use a technique here, and let's use this. Okay, let's try solving this. This is a one-time understanding. Okay, if you understand it once, that's it. Okay, you can do it. These kind of problems might be there, so I don't want to leave any of these techniques out of the syllabus. Okay, just I'm doing it because we are studying the entire analytic function. It's very important. So if you write down fz, you can just write it down as u plus iv, and then I will write down another function I of fz, and you can write it down as iu, and multiply I square, so it will be minus 1 minus 2. Right? So these are the two things that you can write down on this side, and here what you can do is you can just add up. Okay, we'll just add them up, so it will be 1 plus I. You can do it in any way you want. I'm just putting one on the below the other and adding it up. Okay, and here you can just take the real part and the imaginary part. The real part is adding up, so it's very simple, right? U minus v plus I can take common, and this would be u plus v. Okay, this is the technique we are going to use, and let me just show it to you. Okay, and then what I can say is I will just differentiate it. I've written it as small fz, that's the analytic function. I'll just write it as capital Fz. So capital Fz is 1 plus I into Fz, okay, so that's simple. Is equal to this one, you can use any notation, okay, I don't mind, but I will just take out capital U and maybe I'll write it like this so that you remember, and then this would be capital V. Okay, so I hope it's clear to you. It's very simple now. Fz is equal to 1 plus I into f of z. Okay, and then capital U is equal to U minus V, and capital V is U plus V. Okay, so when you write down in your exam, please make sure that you take a bit care if you write down count down capital U and small u. Okay, if you write down a different symbol also, it should not be a harm. Okay, there is no such standard method, you can just use any method you want. Okay, so I have this function now. What I can do is I can actually find out the analytic function. How? Let's see. So that means see, you're given, okay, now what you're given is this, what you're given is U minus V, and my U minus V is capital U. Okay, I've taken it as capital U, so I'll just write it down as capital U is equal to, I'll just write down the term on the right hand side, x minus y, this is x squared plus 4xy plus y squared. Okay, so that's it. So now what I do is I'll just take out del u del x. We are going to use the Milne Thompson method now. Okay, how? We're going to just take this del u del x here. Okay, and let's just do it. Maybe I can consider this is the first function and the second function, so that I don't need to open up and expand. I can do it fast, right? So if I consider this is the first function, del x of x minus y is just 1, because y is not there, so just 1. So that means the first function differentiation, I'll get x square plus 4xy plus y square plus, now I'll take this as constant, this is the first function, and I'll differentiate this one. So del x of x square is 2x, and then 4xy is just 4y, right? So you can write it this way, that's simple. And then I can just directly go for phi 1 z0. We're just taking out to be the real part. See this is the real part, u minus v. There is no I here, so we're not talking about v here. That means we are taking the first function as del u del x z0. X is z, so this is z square plus there is a y there, this is 0, so 0 plus again there is a 0 plus this is x minus y, x is z minus 0, this is 2z plus 0. It becomes simpler. So this is z square plus z into 2z square, so this is 2z square, which is 3z square. So I got 1, right? Let's do it for v. So sorry, not v, with respect to y. So I'll just do del u del y now. Okay, and I'm just going to do it anyway. So differentiate this first function, this is minus 1, keep the second one as it is, x square plus 4xy plus y square plus, okay, first function will remain as it is, second function with respect to y, x square, so this is 0, this is 4xy, so this is just 4x plus 2y. Let's do it now fast. Minus 1, this is phi 2 z0, so this is z square plus 0 plus 0 plus x is z minus 0 into 4z plus 0, right? So we get it here to be minus of z square, and then it is 2 into 4, not 2, z, sorry, this is z, please don't mix up, 4z square, so this is plus 4z square, so this is again 3z square. So you've got this too, now you can easily do it, right, and find out the analytic function very easily. You have to just, the only method that we use is this. Okay, so now what we do is we find out fz. Please remember, capital U is only applicable when you are taking capital Fz, not the small fz, right? So capital Fz is equal to integration of, I will anyway write it so that we are clear, minus phi 2 z0 dz plus c, right? I is there, sorry, minus I. So what is my phi 1? This is 3z square minus I, again 3z square, and then this is dz plus c. So we can do it, right? I think I can take out 3 common here. Z square also can be taken common. So if I do that, this will be 3 times of 1 minus I, right? And integration of z square dz plus c. Check. I hope I'm doing it correct. Okay. So 3 into 1 minus I into z cubed by 3 plus c. I'm not given any limits, okay? That's why we are putting c there. It should be simple. So which is equal to z cubed 1 minus I plus c. So I have this now, but I don't need capital Fz, I need small fz, right? So if we just see here, if we just check here, capital Fz is 1 plus I into small fz, right? So that means small fz would be capital Fz divided by 1 plus I, right? Don't get confused here, check this and you'll remember this. So I can just simplify this z cubed into or divided by just wait, okay, fz is equal to capital Z, okay, this is this, so this is fz, so your fz is this into 1 minus I, right, and divided by 1 plus I. Okay, I hope I did it correctly. Oh sorry, this is multiplied. Oh sorry. This is not divided by, right? This is multiplied here. So this is z cubed, fz is z cubed into 1 minus I. So just write it down as 1 minus I, and then this can be written as 1 plus I, okay, plus c divided by 1 plus I. So c divided by 1 plus I is again a constant. I can take it to any other constant k. You can rationalize it, even if you don't rationalize it, it's fine, right? But let's just do it anyway. For the sake of simplicity, maybe this I can write it down as 1 minus I, 1 minus I, and this would be 1 plus I into 1 minus I कर लेते हैं, plus k, this is k, let's say I take another constant here, that's it. Let's do it once only. 1 minus I and 1 minus I, so it will be a square, and then this will be, I think, minus 2I, right? Just check, minus 2I, because this is 1 square and then there will be a 1 I square, so 1 square minus 1 square will get cancelled, and minus 2AB, so 2 into 1 into I, so minus 2I, yeah, is correct. And 1 plus I and 1 minus I is 1 square minus I square, so minus minus plus, so this will be 2. So just do it, you should get this. This is z cubed plus k, so 2 gets cancelled. This is minus I, okay, it gets simplified quite nicely, z cubed plus k. That's your answer.